Okay. All right. So in front of you, hi Para. In front of you, you have the worksheet that has a little ice cream cone. And all of these numbers are part of the real number system. Are we ready? Okay. And the first ones we're going to start with are natural numbers. So when you're little and you learn to count, these are the ones they start with. So next to natural numbers, I'm abbreviating, there's a line. Will you write counting numbers? And then under it, if you want to like put an example, so these are 1, 2, 3, ... What did I not include with the natural numbers? What did I not start with? 0. So when you're little and we teach you to count, we don't go, okay, ready? 0, 1. No, natural numbers are just counting numbers. We start at 1. Okay. Now let's drop down to the next oval, whole numbers. So whole numbers are just natural numbers. So go to the whole numbers. So whole numbers are natural numbers that include 0. So it's the counting numbers plus 0. So on the line, counting numbers and 0. So under the line, you could put like 0, 1, 2, 3, ...
Welcome,
Well, hello, everyone.
Hi, Natalie.
Do you guys have homework to work
Hi,
on?
Natalie.
Okay.
Hi, Gabby.
Okay. All right, here we go. Integers. So we spent a lot of time on integers last year. If we were in my classroom, I would say, look at my number line. What are integers? Integers are all the what? Think of the number line that's in my room. What's on that number line? Negative numbers, positive numbers, and what's in the middle? 0. Okay. So integers. So go to the line next to integers. And integers are positive and negative whole numbers plus 0. I'm putting positive slash, if I can spell, negative numbers, what's that chord? Plus 0. So can you see how I'm adding? First, it was 1, 2, 3, 4, 5, 6. Then it was 0, 1, 2, 3, 4, 5, 6. Now it's negative 3, negative 2, negative 1, 0, 1, 2, 3, 4. So I keep adding on. So you could put a couple of examples, negative 2, negative 1, 0, 1, 2, ... Actually, you could do the dots in both directions, right? Those go in both directions. And if you notice, the circles are getting bigger. The ovals are getting bigger. So natural numbers is a little bit smaller than whole numbers because I added 0. Integers are all of those numbers plus negatives. Now I'm to rational numbers. It's the biggest scoop on the ice cream cone. I'm going to clear this. And this is what our lesson is about, rational and irrational numbers. What word do you see hiding in rational? What word is in there, Tariana? Ratio. And I'm doing that in 6th grade right now. Do you remember ratios? The ratio of boys to girls, the ratio of cats to dogs. Okay. You can write ratios 3 ways, right? Do you remember? So if I say the ratio of cats to dogs is 3 to 2. So what were all the ways we could write them?
Oh, yeah.
You could do 3. You could do 3, 2, 2.
And then the one crocodile.
The colon, and then what's the other way you could write it? Fraction. Okay, so this is the one I want to focus on. Rational numbers can be written as a ratio, a fraction. So if you can write a number in fraction form, it's rational. It can be put into a ratio, rational. Okay, so our little definition that we're going to write on the line, we're going to write can be written as a ratio or fraction with a non-zero denominator. So we're going to write can be written. You might have to go down below the line, sorry. As a ratio, or in parentheses, you could put fraction. With a non-zero base. With non-zero, not base, denominator, sorry. So if I ask you if a number is rational, you have to think, can I make it a fraction? Can I make it a ratio? Can I write it with a numerator and a denominator? Okay? Now, the irrational numbers are the little cherry on the top. So in this lesson, we have to be able to tell the difference between a rational and an irrational number. It's teeny tiny at the top. So what does that tell you about the amount of irrational numbers? Small. The big loop for rational numbers is the biggest one on the page. So most numbers are rational. A handful are irrational. Okay, so go to the little cherry on the top. I'll switch colors here. So if we were in Mr. Leonard's class and we put a prefix in front of this, what does this mean now? Cannot be written as a fraction. Meaning opposite, irrational. I can't write it as a fraction. So that's what I wrote. Cannot be written as a ratio or a fraction. So we're going to write cannot be written as a ratio, or in parentheses, I'm going to put fraction. Now, there are two lines. On the next line, I'm going to give you a hint at what you're looking for. Okay? These would include, so I'm going to put includes, well, maybe. Please write this because this is what's on your quiz. It includes the square root of any non-square numbers. I'm going to abbreviate square. Square root of any non-square numbers. Okay. Okay. Actually, let's do this. Flip that if you're caught up with me. Flip this paper on the back because it's blank on the back. And I want to add a couple more things about rational numbers. So flip your paper over. Does everybody have this? Because I'm going to hit clear. Okay. On the back of your paper, I'm going to give you a couple of hints about the rational numbers. Okay. Rational numbers are any numbers that can be written as fractions, as ratios, right? They also include, so let's make a list. Oh, let's do that, like a bullets. So if you can write it as a fraction, it's rational. And can you write, like, if I put the number 5 up here, is that a rational number? Well, it's not a fraction now. Could I make it one? Yeah, what do I put under it? 1, okay? What if I had, we can do that. So if you want to add a couple of examples. Or what if I said -2.5? Does that one count?
Yes.
Yeah, it's a mixed number, but I can make that an improper fraction, right? I could do 24/2. That's a fraction.
Pretty much any number.
Yeah, it is. Pretty much any number. Right? Because any whole number, I just need to put a 1 under it, done. It can be a mixed number. Okay, now what if I give you a fraction? Or not a fraction, a decimal. What if I said 1.25? Is that a rational number? Can that be written as a ratio, a fraction?
Yeah.
What would it look like?
1 and 1/4.
1 1/4.
Big brain.
Okay? You guys are so smart. So decimals work. All right, now I got a tricky one for you. What about this decimal? 0.333333333. It's going to keep going on forever. Is that a rational number?
Yes.
Can it be written as a fraction?
Don't think so.
What fraction is it?
1/3.
1/3.
What? Are you right?
Yep, he's right. So they can be decimals that both terminate. So that means they stop. This is a terminating decimal. And they can also be decimals that repeat. They have to have a repeating pattern though. So 0.33333 is 1/3. 0.66666666, you know which one that is?
1/6.
2/3.
Wait, what?
Yeah, okay.
That's it. That's it.
So if I can do fractions, I can do decimals. What if I wanted to do the square root of 25? What's that answer? 5. Is that rational? Yeah, what do I have to do to it to make it a fraction?
What?
If I want to make 5 a fraction, what do I do?
Oh, I don't want to.
Yeah, put a 1 under it. So I can also do the square roots of perfect squares. Now this only works if the number inside is a perfect square. If I put 81 inside, what would it equal? What's the square root of 81? 9. That one works. What if I put in the square root of 72?
Oh,
No, 8.
8 times 8 is 64.
Oh, wait. No.
7 times 7, 49. Oh, that's not big enough. Is that one going to work?
No.
No. So this one would not be rational. So where would it go?
You got it there.
Irrational. Okay, you guys are so smart. Okay, so now we're going to go through. I want you to, you're going to help me. We're going to put all the little numbers. Do you see the number sprinkles?
Yeah.
We're going to take the number sprinkles and put them in the right location. So I'm going to try, I should have put a copy there. That's going to be too big. Okay, so here's my little cherry on top. And then I've got what? 1, 2, 3, 4. Can I do it? 1, 2, 3. Oh, kind of. 4. My cherry's off center here. There's my irrationals. Okay. So let's label them. So this is the irrational. And then this one is natural. And this one is whole. And then this one is integers. And the bottom one is rational. Okay, so we're gonna we're gonna put our little sprinkles on here. Okay, the first one, oh, what color? Let's do red. Okay, the first one is 0. Where does 0 belong? Look at your definitions. Whole number, it's a whole number. Where else could it go? It could be an integer,
Rational number.
and it's rational. If it's in any of these circles, it's automatically rational. I have 0 halves of the cake left. I have 0/4 of the bread left. Okay. How about the number 1? Natural, right? Little kids start counting 1, 2. So if it's natural, it's also, is it a whole number?
It's also.
Yeah. Is it an integer?
It is.
Yes. Is it a rational number? Yeah, 1/1. Okay. How about 2? It is a whole number. Is it a counting? Is it a natural number? Yes. 2, 2, 2, all the way down. Okay. Well, 3, same bit, right? 3 is a natural number. It's a whole number. It's an integer. It's a rational number. Okay. 1.5.
Rational.
Why is it rational?
It's 1. You can make it to, yeah, 1.
It's a 1.5. You're right. It's rational. 1.5. Good job. Well, it's also a terminating decimal. It's a decimal that stops at 0.5. Done. Are you writing these on your ice cream cone? So I got little sprinkles all over mine. You will too. Your ice cream cone should look like mine right now. Well, probably nicer, but okay. 10.
Rational.
Well, it's definitely rational. So if it's rational, can I go backwards? Is 10 an integer? Yes. Is 10 a whole number? Yes. Is 10 a natural number? Yes. How about 3/4?
Three
It's
fourths.
a, it's a rational number.
It is a rational number, so 3/4 rational, okay? How about 0.009? Yes. How do I read, how would you, I didn't read that correctly. I read it like a scientist. How would a math person read that?
9 100, no,
Nine.
9
9 thousandths. So what does that mean? Rational, you got it. 0.009, okay? Who's next? 5/6. Yeah, that's easy. It is a fraction. It is a ratio. 5/6. How about, thank you, sorry, we're in the middle of teaching. 1.76. Oops, hang on, that's a 7. 1.76. Who said it?
Me.
Rational. It is rational. You could write 1 76 hundredths, or you could say that's a terminating decimal. That makes it rational. You got it. 1.76. Good job. Okay. How about 3/2? Rational. It's a fraction. 3/2. Okay, almost done. How about x squared? Let's think about it. Let's give it some numbers. What if x is 2?
Two the same one.
Yeah, so what is that? What is 2 to the second power? 4. Okay. What if it was -5? What's -5 times -5?
It would have been 25, right?
25. Okay. So what are these looking like?
Rational number.
They are rational numbers. Yeah. Okay. And that's why you're getting the hang of this. Most all numbers are rational, right?
Whole numbers.
So let's see, where else were we? P divided by Q. Rational, it's a fraction. Yeah, I don't even have to. I don't even need to know what the numbers are. P divided by Q is definitely, it's a fraction. It looks like a fraction. Okay. How about pi?
Yeah, I know.
It's rational because it's,
Okay, so look on the back of your paper. You said that rational are, this is a decimal, right? 3.14159. That's as far as I can remember. Okay. There people know them, a lot of them. Okay. Tell me something about this decimal. Cabrini.
It don't repeat.
It does not ever repeat. They've taken it out millions and millions of places, like decimal places, and they can't find any pattern that repeats. Not even long strings of numbers that repeat. So this is, it doesn't terminate, right? It doesn't stop. So it's non-terminating, non-repeating. So this is the exception. What is this number?
Irrational.
It's irrational. So up in your, on the little cherry, you can add pi. So that's an easy one to memorize. Pi is irrational because it never terminates and it never repeats. Okay. All right, who's next? Okay, now what if I use this number? We use that for pi all the time. But if I pick 3.14, where does that go? Rational, because it's a terminating decimal. 3.14. Okay. Square root of 100. Can you take the square root of 100? What is it? Somebody said it. I just heard it. 10. So 10, where does that go? Is 10 a natural number? Well, yeah, look, it's already in there. So square root of 100 is a natural number. Square root of 100 is a whole number. Square root of 100 is an integer. And square root of 100 is rational. Okay, let's lump them together. -1, -2, -3. Where do they jump in?
Integers.
They jump in at integers, so squeeze them in there. -1, -2, -3. If it's an integer, it's also rational. Where am I going to put them? -1, -2, -3. Okay, last one. -2/17. Where does that one go?
Integral. I mean ratio.
Rational, right? Rational because Why is that rational?
Because it's got the.
It's a fraction.
It's a fraction.
So Donna says she was supposed to do a quiz, but you didn't send her a quiz. Did you email her that?
I thought I sent it to him last week. That could be my bad. So if she doesn't, I'll send it to her. But have her look through last week's stuff.
Okay.
But that could be.
In the box or?
It should have been in the box. Yep. Okay. All right. So the only other one, can we add another one that's not on here? If I take the square root of 5. Okay, stop talking. If I take the square root of 5, do I know that one? Is that a perfect